top of page 164. And here's one of the graphs that we had on our colored paper. Here's the square root graph. You would have this point, and this point, and this point clearly labeled on that graph and have that shape. And then if you were asked to graph the square root of x plus 2, that plus 2 is outside the function, and it will move it up 2 units. Okay? Now, if you had a minus 1 outside the function, it would move it down 1 unit. What are some things that could be tricky? The blue one. I've seen sometimes it written like this. You see what happened? Just move the 2 to the other side. Okay? Me personally, I like the y by itself. I like this of the blue way better. And then I see my plus 2 and move it up 2. So if I had this minus 2, I would think to myself, I want to add 2 to both sides so that I can see that it's a plus 2. But there are some people who always like the translation up and down with the variable, so they move the 2 over, and then both the x's and the y's are liars. So it's a different way of teaching it that way. Sometimes they say, well, if we always put it with the y, then it's also the opposite. But I'm like, no, I like it just easy. Only my x's are liars, and I put the 2 on that side. Same thing with this green one. It could have been written like this. That's exactly the same thing. You would have to know that that would take our regular square root graph and move it down 1 unit. So these could be written in those forms as well. So one of the things is we're going to learn techniques for drawing the graphs, but then also learn that, oh, the algebra could show up in a bunch of different ways. Like, how else could I attempt to confuse you? Oh, what if I wrote it like this? Could that confuse you? Possibly. What have I done? Just put the 2 first. So sometimes we have to rearrange things until we're in our comfort zone and be like, this is the same as that. It's still going to move the graph up 2 units. But it's amazing how you change one little thing and it can throw you off, right? You've probably seen that before. And you got to a question on a test or a quiz in a previous math class and you're like, I had no idea. And then someone says, well, it's just this. And you're like, are you serious? It was that easy? But it's just sometimes a little thing can throw us off. So trying to see all of those things right away. And then here, another one of our graphs. Here are the key points. 1, 2, 3 for your x cubed graph. And this x plus 2 cubed. X's are liars. That would move it 2 to the left. X minus 3 cubed would move it 3 to the right. And we call these horizontal translations. So the original graph looks exactly the same shape, right? On the blue graph, here are the 3 points. On the green graph, here are the 3 points. And they all got moved the same way in the same direction. And that's our shortcut for graphing. The textbook will sometimes summarize things in the end. Sometimes these are really good. Sometimes I'm like, actually with the notation here, we're going to skip this. I think it's much easier to understand with just numbers rather than adding H's and K's. So let's go to example 1. And what's going to happen is the textbook always has a worked example, but we will do the one off to the side together. The nice thing about doing the one off to the side together is you can see if I had this question on a quiz or a test, what kind of work do I need to show to get it done? So here's the graph of g of x. Sketch the image graph after each translation. Write the equation of the image graph in terms of the function g. State the domain and range of each function. So first of all, this question is asking a lot. It's asking us to do 3 things with each of these, A and B. First of all, a translation of 4 units to the left is actually not hard. I'm going to do A, all my work in A in blue. So I'm going to take this point and go 1, 2, 3, 4 to the left. 1, 2, 3, 4 to the left at that point. 1, 2, 3, 4 to the left at that point. 1, 2, 3, 4 to the left. Play connect the dots. Oh, so much fun. And we've graphed it 4 units to the left. Now, if you're a normal human being, once you do something, you feel like, oh, move on. And you'd probably jump to B right away and lose a lot of marks on this question because technically we only did this part, right? We've only completed the sketch. We're like, ooh, it says write the equation. We haven't done that yet. And in this, another thing I'm going to point out as we do stuff is that there is key language in a question that's easy to miss, okay? I'm going to show you how to do this, and you'll go, okay, that makes sense. And then you're going to get to a test and put up your hand and say, what does this mean? Because it makes sense when I do it, because I tell you what it means, but you need to know, like, what does it mean when they say, write the equation of the image graph in terms of the function g? And in particular, I'm going to double line this part here, and I'm going to, whenever you see in terms of dot, 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 you need, in this case it's it says in terms of the function g, you will need the function g on the right side of an equation. If it says in terms of x, you will need x's on the right-hand side of your equation. So I need to write an equation. An equation has an equals sign, okay? And so I'm going to write my equation as y equals, and on the right-hand side, I need the function g. Well, if you move things left and right, that has stuff inside the function. X's are liars, so if I move it 4 to the left, I'm going to write plus or minus a plus. And this is in terms of the function g. There. I was doing part A in blue, I'll change that to blue. So now I've done command number 2. I did the yellow, I've done the green, I read the question again, and it also says state the domain and range, so I need to, for the blue one, talk about its domain and range. And right now, I will practice writing domain and range in both forms. So domain is your x values, range is your y values. Have to remember that somehow, okay? So however you memorize definitions, you need to remember that domain are your x values, range are your y values. And like for me, all sorts of memorization techniques that I've used over the years. Like sometimes I'm like, okay, D comes before R in the alphabet, X comes before Y. I use that to study so many things that I no longer trust it because I'm like, did I use that this time or not? So then sometimes it's better to make you, like I don't know if that's happened to you. You're like, oh, is this one of the ones that I did this for or not? And so then you start to second guess yourself. My favorite is like a student a long time ago just said, well, I just put a Y on the end of the word range, and I call it rangy. Stupid. It has not gone out of my head. And I always, when I think of range, the little Y goes on the end, rangy, and then I'm like, oh, you can't, I don't know if you can put an X on the end of domain. Domains, it doesn't roll off the tongue as nice, but it helps me remember. And the sillier and more unique ways that you remember certain things, the more likely you're going to remember them. There's some. I remember the Native American tribes from the Eastern Woodlands from grade 11 history still, because I made a song, and that song is still in my head. Now one of the didn't fit in the song, but it's actually really like that Native American tribe is actually extinct, and so, like, I remember all of these things now because I made a silly song for it way back in grade 11. So when we remember things, however you help yourself remember them can be helpful. So domain is our X values. When you're thinking about domain, one of the strategies you can do for domain is there a smallest value? Yes. There's a smallest value of -5. Is there a biggest value? Yes. There's the biggest value of 2. Does it have everything included in between those? Yes. So one way I could write my domain is in set notation. And my X values are between -5 and 2. And if I wrote that in interval notation, I would use square brackets because we include -5 and square brackets because we include 2. And same thing in range. Do I have a smallest y value? Yes. Smallest y value is 2. Biggest y value is 5. So in set notation, y is between -2 and 5. In interval notation, again, square brackets because the 2 and the 5 are included. I would write this as 2 to 5. So now we've done all 3 parts of A. We've sketched the image graph, we've written the equation, and we've stated the domain and range. Okay? Reading skills in math include rereading and rereading. It's super easy to miss a part of a question. So whenever you're done a question, my recommendation is, once you finish, reread the question. Okay? This is not something you should use in English class. Like, as soon as you finish a novel, yeah, just reread it. No, that would take too long. But math questions aren't that long. Rereading it is important. And reading every word is important because sometimes they'll change one little tiny word and it changes the question. So attention to details when reading is important in math. Some subjects, attention to details isn't that important, right? You're like, I know I used to be like, okay, I read the first sentence and the last sentence of a paragraph, and if it seems important, I might read more. If it doesn't, I just skip that paragraph. And I can read very fast that way. And some subjects, that's enough. In math, we have to pay attention to all the details. Okay, B. Translation 1 unit up. I take each of my points, I shift them 1 unit up. Play connect the dots, no problem. And now this equation in terms of G is outside the function, and so that +1 happens after. That would be a translation 1 up. And my domain of my green one, smallest value, -1. Biggest value is 6. So I could write it either these ways, same thing, range, smallest value is 3. Biggest value is now 6. And after we do an example, yes, question.
What does the G actually mean?
The G is referring to the original function. So the green graph is saying your y values are your original red graph +1. It was moved up. The blue one, I can't really circle it in red because something happened inside. But inside it said you took your original red graph and moved it 4 to the left. So when we use function notation it allows us to compare the new graph to the old graph. The new blue graph is the old graph moved 4 to the left. So that's where the function notation comes in. And at the end of every question that we do, what I'm going to say is, I'm going to list some questions. So I'm going to get you right now to turn, because the homework questions for this section start on page 169. And you can write above question 1, 4, 5, 6, and 7, but then turn to page 169, circle the question 4, circle the question 5, circle question 6, and circle question 7. And that is the practice for you outside of school. Okay? So at any time I should be able to go, hey, let's look at your workbook. Look at all these ones circled. Have you done those questions? And then you can come in, if you have any questions about any of those, you can come in at lunch and ask.